Okay, now let us start.
Good evening, sir.
Yeah, very good evening. So slide is visible, first slide.
Good evening, sir.
Yeah, very good evening, very good evening. Good evening to all of you. So let us start. So the actually I am Om Prakash Maurya from IIT Guwahati. I am a research scholar, Department of Civil Engineering. So week first is about your right. Okay. So it is visible to all of you. Week num week one introduction.
Yes, sir.
Whatever I am writing, it is visible. Lecture 1, basic concept of fluid and properties of fluid and the fluid flow analysis.
Yes, sir.
And pen is visible, pen also.
Yes, sir.
Okay, fine. So now let us start. So actually the professor have followed these books, the fluid mechanics, the Sinjal Simbala book, right? So now actually basically I have covered a lot of thing in this PPT. So from basic concept to your advanced level, but here we are going to solve some problems. So I have lot of problems regarding that. So overall I'll just go through the your some basic concept regarding the shear stress analysis, how shear stress work applied. As you can see here, it work tangentially, and here you have the tangent. The if your force is working like acting like that on the surface, so you have one tangent component, one is the normal component. So tangent component is generally known as your shear stress. So in fluid mechanics, shear stress are very important, as you know from the Newton's law of viscosity. So actually lot of things I have covered here. As I will upload in the week one your Google Drive, so you can go through and follow the many things. So the some basic concept here, how the velocity formation, how velocity form here, also I have covered here lot of things. So before delay, let us discuss first the lot of questions, then I'll move. If time will remain, then I'll discuss about the concepts. So I have also the lot of questions, but now I want to discuss some new questions. These are questions already I have discussed in the previous NPTEL courses, the previous NPTEL TS. So for today I have the new questions, which is very important. Yes, from here the first question is, which of the following statement is relevant? First one is, the fluid deform continuously under the action of shear stress or even very low magnitude. Second option is, The first option was this, and the fluid deform under constant shear stress. The third is fluid can sustain shear stress when at rest, and fourth one is fluid does not deform continuously under the action of shear stress. So which option is correct? Just please everyone try to write in the chat box. So as I can see. So you can write whether first, second, third and fourth option is correct. Which one is correct? Okay. So Reddy is telling option A. Okay, fine. Navidita Eddi. Okay. Reddy and other student. Ravi is also telling option A. Very good. So other student, please also you just try to write your answer. So I'll wait a few minutes, then I'll discuss. Okay. So here the first one is correct. The first option is correct. The fluid deform continuously under the action of shear stress or even very low magnitude. So this is the definition of the fluid. In fluid you can consider both things. One is your, for example, water, that is a liquid, and another is air, that is gas. You can consider both things, and here some discussion is there, already explained in the what is fluid, and some discussion about your other things, the fluid properties. Please okay. So now I'll move on the next question. So next question is about, so here some important point is also there, as when you will go through this PPT, or I'll upload the PDF, so you will see everything. As you can see here, the your shear stress in a solid is a function of a strain, but shear stress in fluid as a function of strain rate. Remember these things. Many times this question is asked in several exams. And another one is the Newtonian fluid relationship, you know already, that is the linear relationship. Already if you will put du by dy here on x-axis and shear stress on y-axis, so this will form like that, that is y barabar y is equal to mx plus c. So c here is 0. So remember please, and your mu is the dynamic viscosity. For non-Newtonian fluid, this formula is not applicable. So we'll see in the later questions about the non-Newtonian fluid also. So second question is, the bulk modulus of elasticity is independent of temperature, increase with pressure, is independent of pressure and viscosity, is larger when fluid is more compressible. So little bit tricky questions. So please everyone try to give your answer in the chat box. Everyone please try to participate. As we have here joined, so you some get benefits. Otherwise no meaning to join here. So please just try to give your answer, everyone please. The bulk modulus of elasticity, whether is independent of temperature, increase with pressure, or independent of both pressure and viscosity, and is large when the fluid is more compressible. So just I'll give you a hint after 1 minute. So please try to everyone first try to think, then I'll give you a hint how I will think. So tomorrow also I have a session from 5 p.m. from I think 7 to 9, because my this class was scheduled on 29, so I was unavailable due to some reasons. That's why I'm taking on 4, that is today. And but the next class I'll take tomorrow from 7 to 9 with the new questions, new concepts and all. So bulk modulus of elasticity, please everyone try to give your answer. The question second. So no one actually trying, please. At least you write the formula. If you know the formula of bulk modulus of elasticity, that will help you. So just I'm giving you hint. Just try to see the formula of bulk modulus of elasticity in fluid mechanics. From that formula you can guess the answer of this question. So first please everyone try to Google. Everyone Google the questions. Try to Google this bulk modulus of elasticity formula, and from that you just try to think. If you not know the formula, if you know the formula, no need to Google the formula for bulk modulus of elasticity. Okay.
Is independent of pressure and viscosity.
Okay, you are telling C option. Pramod, right?
Hmm.
Okay, fine.
Yes, sir.
Okay, I'll discuss. Okay, C. Ravi is telling D. Okay, fine. Good attempt, everyone. Other student, please also try to participate. This is your not exam. Whether you are wrong or right, that it doesn't matter here. But just try to think what is the question and how to approach the questions. Here you will learn these kind of things. This is not your exam. So here you can make mistake and you will correct. Okay. So two student is telling, one is telling C, Pramod, and Ravi is telling D. But I want to see another answer from another participants, because already 12 students is joined here. So
This is the first question of the session, sir.
no, the first question I have already told. You can see here the first question.
I have let join.
Okay, no problem. So first question was about the statement of that is the definition of the fluid. So the definition was the fluid deform continuously under the action of shear stress of even the very low magnitude. So this was the correct answer for the first question, but now we are looking on the second question, and I have already the explanation also, so you can go through once I upload this PDF. So the for second question, okay. So two students only telling, okay, now I'll discuss about this. If no one want to try. So as you know already the formula for the bulk modulus of here, you can see this formula. So let me just keep it. This formula of the bulk modulus. The bulk modulus K is defined as stress by strain. This is the change in pressure, that is delta P, and strain is change in volume divided by original volume. So here you can see already your K is directly proportional to, or you can see dP or del P you can also write, but in this formula dP is written, so that's why I'm writing. So here you can say increase with pressure, because it's directly proportional to, so you can say it is increase with your bulk modulus of elasticity increase with pressure. Always remember please. And now we'll move on the next question. Here all lot of discussion I have written already, so please go one by one. If you not know the concept behind it, the bulk modulus of elasticity or what compressibility. And one thing remember please, your the compressibility and bulk modulus have the inverse relation. Always remember this type of questions also you can expect in your exam, final exam or competition exam also, the state competition exam or SSC exam. Now the next question is which of the following is true for real fluid? First one is incompressible, second has surface tension, third is viscous. We are talking about here the real fluid, remember, not ideal fluid. So which option will be correct? Only one is correct, only both 2 and 3, only 3, and both 1 and 2. So everyone please try to participate in this discussion. So this is question number 3 for today's session. Everyone please try to give your answer. For question number 3 I think. Okay, I have not written here the question number. So whatever question number, no meaning here. Just to think. Okay. So Reddy is telling option A. Only one is correct. Okay. Good attempt. Ravi is telling B. Both 2 and 3. Okay. Other student, please also try to participate. Just at least write your answer whatever you are getting in your mind. Based on your thinking, based on your the previous year, that is not the previous week knowledge, just try to write here. Okay. Ranjit is telling A. Okay, good. Only A. Okay.
1.
You are telling only one. Okay, Pramod. And Nancy is telling B. Okay.
One, sir.
Okay. Shiva Shankar. You are telling Shiva Shankar?
Yes, sir.
Okay, one.
Yes, sir, Shiv Shankar.
Okay, okay, good. Shiv Shankar. So here
I
question
think
is
1 and
about
2.
what you are telling?
1 and 2.
1 and 2. Okay, good. So just please think on, we are talking about here the real fluid. Real fluid means you can say the, okay, I'll show the answer. So here is incompressible, has surface tension, is viscous. So remember one thing, the real fluid have always viscosity. So option 3 will be correct. So first try to
Okay,
think
sir.
which option will be correct. Yes, 3. In we have the two options, that is your second one and third one. Here the second one and third one. So maybe your second one and third one will be correct. But also second option has the surface tension and is incompressible. The incompressible is not your sufficient. That is, this is not a condition, actual condition. Your fluid may be compressible or incompressible, both the real fluid. But surface tension and viscosity, these two properties have must for real fluid. So option B will be correct. That is,
Both 2 and 3.
yes, always remember please. And I have lot of discussion written in the next one. So about the real fluid, all fluid are real as all fluid possess viscosity. Okay. And second one is the real fluid is compressible and it has some value of shear force. The third one, its surface tension value is non-zero. So remember this thing. And ideal fluid, just here the definition is given. Ideal fluid is incompressible and ideal fluid, remember please, incompressible and it has a value of, oh, someone I think, please unmute. Who is, that is Shiv Shankar. You just try to unmute. Okay, I have already muted you, but remember. Okay. Yes. Incompressible and has the shear force 0. The ideal fluid does not actually exist in nature, but sometimes used for fluid flow problems because for the simplification. An ideal fluid is a fluid that has several properties, including the fact that is the incompressible, the density is constant, that is the rho will be constant, Irrotational, the flow is smooth, no turbulence, remember please. Non-viscous, inviscid, fluid has no internal frictions, remember. So these three conditions remember for ideal fluid. After whatever, here will be the real fluid. Okay, now move on the next question. Addition of detergent in liquid has no effect, increase surface tension, lower surface tension, and light effect. So which option will be correct for your question number this? For I think why is not proper. Yes, please. Everyone try to write your answer. Addition of detergent.
Increases surface tension.
Okay, you are telling increasing surface tension. Okay. So for this question, I will discuss little bit at molecular level how what is surface tension and how it will affect. So before discussing on that, you please okay lower surface tension. Another student is telling. Ranjit is telling okay.
Increase surface tension.
Okay. Pramod is
Increases.
telling increase and Raj is telling increase. Okay. So first I'll discuss little bit the concept, molecular concept of surface tension. Then after I'll ask the again questions. This is. So you have all participant 1 minute more. So another 1 minute please every participant try to write your answer. Then after I'll discuss. So I'll give you some live example, not just I'll just try to visualize, then you might be understand this question. Okay, Ravi is telling C, Gulshan is also telling C, lower the surface tension. Okay, let me discuss. So everyone please try to think. So let us have one surface with some water. You have the some surface. You can think about your surface of your bathroom. Anyone? Anyone try to say anything? No. Okay. So as let us assume as you some by mistake some detergent falling on the surface, what will happen? As you have seen the water particle moving in for away from your detergent. Everyone agree with this point? As the some detergent fall on the surface, the water particle try to move away from the detergent. Everyone agree? So actually this is, have you seen or not this type of phenomena? Yes, everyone. Okay. If you not seen, just try to look with your home experiment. No issue. Now, so what is happening? As you put the detergent, meaning water particle try to move away, means your the water particle, let us, adhesion and cohesion force might be so water particle joined with each other by adhesion force. Remember please, a cohesion force, not a adhesion, cohesion force, right? So as detergent will come or will you will put on the water, in the water, what will happen? Adhesion force will be loose. adhesion force will be decrease. As adhesion force decrease, water particle move away from the detergent. Meaning, and your surface tension in water okay, surface tension in water is due to your adhesion cohesion force. So cohesion force will decrease means what? Your surface tension will also decrease. So means option C will be correct for this. And what is surface tension? Let me just try to discuss here. Let us assume if you have some container and water is filled completely. Water is filled up to that. So on the surface, because here is lot of water, below the surface lot of water, and all water try to pull down these the surface water molecules. These surface water molecule, the all this the below one the fluid particle, below one water particle try to pull downward. As the things will downward, what will happen? Your surface will be like that. Your surface will be like that. In the zoomed view I am showing you. So here what will happen? Here tension will be created on that. On the surface, tension will be created. So this is known as surface tension. As you can see in the experiment also, you can do experiment in your home. Let us take, you take just water in the glass. That is, the glass should be on your not steel glass. The glass should be transparent. So when you will put water, you will see your surface will be like not completely straight. The surface will not completely straight. Remember please. As you can see, it may be like that, little bit lower, or sometimes you can see like that also. This is another concept, the meniscus effect. So we'll discuss later, but remember this thing, the concept about the surface tension. So option D will be correct here. Option C will be correct, lower surface tension. So the formula of the surface tension is force divided by length. Surface tension of liquid, force divided by length. So here a lot of your explanation is given. As you can go, once I'll upload this PDF, you can go through. And if you have any doubt, you can discuss in the next class, which I'll take on the tomorrow, same time, 7 to 9. The next question is, mercury does not wet the glass. This is due to the property of liquid known as viscosity, surface tension, adhesion, cohesion. So this is also important question. So everyone please try to give your answer. The mercury does not wet the glass. This is due to the property of liquid known as viscosity, surface tension, adhesion, cohesion. Cohesion, okay. Raj is telling cohesion, okay. Other participant also try to give your answer. Okay. Ravi is telling surface tension. Reddy is telling D option, that is cohesion. Gulshan also telling cohesion, D option. Cohesion also, the Ranjit is telling okay.
Cohesion.
Okay, you are also telling, Pramod telling cohesion, okay. Okay, good
Cohesion,
response.
sir.
Yes, cohesion. Okay, let me just show you. Okay. Yes, it is due to cohesion. And how cohesion? Here you can see. What about I was telling previously about the surface tension? Due to the particle is, whatever the here particle is, the this particle is try to this pull down your surface particles. So here tension will create on the surface. So this is known as your surface tension. But here is the question is different. The mercury does not wet the glass by which properties? So property is cohesion, because mercury have cohesion. So due to the cohesion, what will happen once, I think another picture I have also or not. So here you can see already the liquid on the non-weighted surface, the surface tension dominating and attractive force on the surface, here just given the figure, and here is surface attractive force. When the attractive force to the surface exceed surface tension, the liquid weight the surface. So here is the concept is, if the surface is without any water, once you will without any liquid, as I'll say, I can say, once you will put here the water, what will happen? Your, remember please here, when the attractive force to the surface exceed the surface tension, means let us suppose you have the surface tension force, and when surface tension force will be less than the attractive force to the surface, means your surface have also the attractive force. That is the, here I will write the force attractive due to surface. Once this condition will happen, your surface will be like that. That is the wet condition. Remember please, wet the surface, and here in this condition the surface will not wet. So here the condition will be your, the attractive force due to the surface, that is the attractive force due to the surface will be less than your tension, surface tension. And this surface tension is due to what? As I was previously telling, due to the cohesion. So finally, surface tension is a second answer, but first, if the cohesion is uh, in the option, so you will go through, you will select this cohesion, right? Always remember. So if any liquid, not mercury, if any liquid have this condition, means your surface tension force is much, that is the greater than your surface attraction force. In this condition, your condition will be non-wet, and if just opposite, the condition will be wet. So for example, in case of water, here the example will be water, and here example will be your Hg, that is mercury. So now we'll move on the next question. Next question is, the property of fluid which enables it to resist tensile stress is known as compressibility, surface tension, cohesion, adhesion. The property of fluid which enable it to resist tensile stress is known as, very easy question. So everyone please try to give your answer. Okay, Raj is telling cohesion. Other student please also try to give your answer. Just think on that. First think on that, then you try to attempt the questions.
It is compressibility.
Compressibility, okay. Gulshan is telling surface tension. Okay. So we are talking about here the tensile stress. So remember please. Okay. Remember these things we are talking about here, the tensile stress. Keeping in mind, then try to give your answer. The property of fluid which enables it to resist tensile stress. Okay, surface tension, Gulshan is telling, and Ranjit is telling cohesion, Ravi is also telling surface tension, B option. Okay, let us discuss about it. Anyone want to give the answer? Just I'll give few seconds.
Cohesion.
Cohesion, okay. Shiv Shankar is telling cohesion, okay. Let us discuss.
Cohesion.
Okay, you are also telling cohesion, Pramod. Okay, so let me just show you. So here answer is surface tension. So let us just I want to read the definition. Hopefully you will get. So the cohesion is, what is cohesion? The force of attraction. Remember these things. The cohesion means force of attraction, and adhesion, the force of attraction between molecules, of course, of the liquid by virtue of which they are bound to each other to remain in one assembled particle is known as force of cohesion. Remember please. Adhesion, the force of attraction. This is also force of attraction, your adhesion. Force of attraction between unlike molecules. Force of attraction between like molecule, and here unlike molecules. Remember please. Force of attraction unlike molecule, and here like molecule. That is between the molecule of different liquid, or between the molecule of a liquid and those of a solid body when they are in the contact to each other. Like in the glass, as you can see, some water molecule already attract. So the glass surface and water, between these two the adhesion force work, but between the water molecules cohesion force work. This is the example. This force enables two different liquid to adhere to each other, or liquid to adhere to a solid body on the surface. So adhesion force, here is example of adhesion force as I am telling. The surface tension, now let us read, is a elastic tendency, remember please, is a elastic tendency of a fluid surface which make it required to least surface area possible. Remember please. Why least surface area? As I was discussing previously, as we will take, let us take, if you will take the water, what will happen? Your fluid will be like that, little bit lower, meaning, but the surface area of your glass will be how much? This is the whole surface area, but here little bit less. So that is this much area, this much, and here also this much, because at the end your surface will be little bit downward, not straight. So this much area and this much area will be unweighted. So it means the surface tension try to make the acquire the least surface area possible, least surface area, and it occur at the interface of two liquids, interface of the two liquids, remember please, due to intermolecular force of cohesions. This property enables the liquid to resist tensile stress. Remember please, always remember these things. So your option will be correct, that is the surface tension. And the compressibility is the ability of fluid to change its volume under pressure. So compressibility is another concept. Its ability of fluid to change the volume it's under pressure. When you will apply the pressure on the fluid, so what will happen? The volume will be changed of the fluid. So this is the, and of course key point is given here. So once you will read, you will get something. Next question is very interesting. If you are given 5 sample of liquid having a fixed density, identify the increasing order of height of the sample will reach in the following capillary tubes. So this is the tube, remember please, this is the tube, complete tube. This is one tube, this is your tube number B, this is complete, this is not separate tube, this is a complete tube. I think figure have some mistake, so for you I'm just giving the easier. So here you have the 4, 1 tube, 2 tube, 3 tube, 4 tube, and the diameter is different. Here D1 is D2, D3 and D4. So now based on this, you just try to give the answer. The increasing height of the sample will reach the following capillary tube. Meaning which, okay, first you try to think about the question and try to give your answer. Then I'll discuss. For question number, whatever question number, everyone please try to give your answer first. Just first think about the question. Question is very interesting. First think on that and then try to give your answer. For this question you have 5 minutes. Very interesting question. Okay, Raj is telling A, B, C, D.
Second one, DCBA.
Okay, D, C, B, A, second one. Okay. Reddy is telling DCBA. Okay, good. Other student, please also try to give your answer. Just first try to attempt the question. Whether you will wrong or right doesn't matter here. Okay, option B. Uzita is telling option B. Okay. Ravi is telling okay. DCBA B. Okay. Means all three student is telling B. The first is telling ABCD. DCBA. Less area, more pressure. Okay. So now I'll give you hint about it. So if you remember the formula of capillary rise, then you can try to, now you will try to everyone give the answer for this question. Just think on that. First try to think on that.
B, DCBA.
Okay, DCBA. So here bit confusing, so it's better you can write your answer in the chat box, whether 1, 2, A, B, C, D, you can write 1, 2, 3 you can write here, or you can write the option also. So okay, so option 2, yes, good. Okay, Wilson is telling option A. Okay, I'm reading the question very carefully. Maybe I think the question statement is not very clear. Okay, but I have already tried to explain you.
Option B.
Option B you are telling, okay, but already I have explained you about the question. Means you have the different type of tube which having the diameter different. That is the D1, D2, D3. As you can see, D1 is greater than D2, D2 is greater than D3, D3 is greater than D4. So in which tube the capillary, that is the water height will be more? This was the question. Option A. Okay. So let me just discuss. Very simple here the understanding. So capillary height is about the sigma and your, here is the gamma, that is rho ZD, I think, rho ZD, and here cos theta, I think. Okay, whatever the. So as you know here, your capillary height is inversely proportional to D. The main concept is this. So meaning, as your D will increase, the height will decrease. This is the main concept here. As your D will increase, the height will decrease. So meaning D1, the height of D1, and if I am writing the height of D1, then let me write little bit small. Height of D1 is greater than, first D1 greater than D2, greater than D3, greater than D4. Okay, so here what we will write, let me write here H1, H2, H3, H4, meaning the smallest D have more height. The answer will be this one, that is the H1 have less, the capillary height, and your H4 will more. So and H2 and H3 in between. So now you can think which option will be correct. So the question is talking about here, identify the increasing order. Increasing order means first you write the smaller one, that is the H4, then a smaller one, that is your H2, H3, then a smaller one H2, and then H1, bigger one. So of course your H1 is H4 is corresponding A, H3 is your, H1 is corresponding your H4, I am talking about H4. We are right here. No, this is talking about your increasing order, means the H1 have lower one, H1 have lower, then H2, then H3, then H4. So H1 is corresponding A, H2 is corresponding B, and H3 is corresponding C, and H4 is corresponding 4. So definitely A, B, C, D your option will be correct. Hope all of you got it. So if everyone got it, you can write yes in the chat box. So I'll move, because this is very important question. So I need you just write in the chat box yes if everyone got it. Okay, fine.
All are correct, sir. Yes, sir.
Yes,
Who is correct answer?
the A option. Oh, I think
A option. Okay.
you not got it what I was telling. Okay, let me explain. Once I'll explain, remember please. First one, yes, first one is correct, but how maybe some student having confusion regarding that. So let me explain in another way. So let us assume you have a tube. Here you have this bigger one tube, and another the same box and same liquid, that is water, but you have the smaller tube. So if liquid will this much, so in the tube your water will be here if the liquid is this much, but in a smaller tube your liquid will be here. How? Because your height, this h is inversely proportional to 1 by d, meaning as your d will decrease, height will increase. As here d means the tube d, this is small compared to this, so height will increase. So if this is a and this is v, so in which your height is more? In hb will be greater than ha. So if I tell you, just you write in the ascending order, ascending or increasing, whatever, yeah, increasing order. So how you will write? The increasing order means first you will write the smaller one. Smaller one will be ha, then then bigger one hb. So similarly here you have the 4 tube. So as your that is the diameter is decreasing, the height is in the diameter is decreasing, the height will what? Height will increasing. So here is asking about increasing order, definitely your ABCD will be correct. So hope everyone got it. Here the formula is given 4 sigma. Remember here, I think here is 4 sigma cos theta rho ZD. Yes, sometimes you can write this formula like that, cos theta divided by gamma, unit weight of water. This is D and this is equal to rho Z. Okay, so now we'll move on the next question. Here the explanation is given very well. Okay, small numericals. The question is a plate of 0.010 mm distant from fixed plate move at 10 centimeter per second and require a force of 1 Newton per unit area, that is 1 Newton per mm square, to maintain this speed. What would be the fluid viscosity between the plates? The option is given 10 raised to minus 3, 10 raised to minus 4, none of the above. Which option will be correct? Everyone please try to first calculate, then you try to write your answer for these questions. Very important questions. So everyone please. After this question I will take 5-minute break. So you can also take. Then after I will discuss another questions, very important questions, very interesting questions. So everyone please just you have 5 minutes because this is some bit calculative questions. So after 5 minutes I'll discuss. First to think on that, the concept of when you have very small distance between the plate, then what will be the conditions and which formula you will apply here. This also need to remember. Okay. Whatever you are getting, you just try to write your answer. Remember, one option is, the first option is 10 raised to minus 3, second one is 10 twice, and another one is 10 raised to minus 4, and last one is given none of the above.
Please derive the answer, sir.
Yes, what you are telling?
Please derive the answer, sir.
Yes, I'll show you. First I am waiting if anyone trying, so just I want to see whether anyone trying or not. Okay. So already 17 participant is there. Okay, let us discuss. Very simple question, not very hard. So here you have one plate, fixed plate, already in the question given fixed plate. And another one is the plate is moving with 10 centimeter. Another plate is here with moving a velocity of 10 centimeter per second. One thing is also given, the distance is very small, as you can see here. This distance 0.010 mm. Mm, remember please here, in the mm is given, not meter. That is a very small. I think it should be meter, but I don't know. Okay, so how you will approach, just I am going to explain you. And you need the force per unit area, that is your stress is given 1 Newton per mm square. So now you need to calculate the viscosity. You know formula, one formula, tau is equal to viscosity divided by del u by del y. That is change in velocity with respect to y. So always remember, if the distance between the plate is very small, as you know your velocity variation is, if this is velocity, if this is depth of the flow, your velocity variation is like that. In laminar flow, parabolic, remember please, parabolic. If okay, like that. But here your distance is very small, as you can imagine, 0.01 mm, very small. Means here your velocity variation, we assume it is linear. Means here is on the surface is 0, as you know the no slip condition, and here is velocity is equal to your plate velocity 10 centimeter per second. So you can write this formula, tau is equal to mu velocity divided by y. What is y here? Y is the distance between this. So you need to calculate viscosity, tau into y divided by velocity. So what is tau? Tau is 1 Newton per mm square divided by another one y is in mm 0.01 mm and your velocity 10 centimeter per second. So for mm I want to just write this one 100 mm per second. So now you can calculate. Now you can calculate very easy. Okay. So after your calculation, what you will get? One Newton per mm square into 0.01 mm into 100 mm per second, and this is viscosity. So mm and this mm will be cancel out, but you have another mm also. So 1 and not 10, that is the 100. Once you will remove this one, you will get another 20 here. So what? 1 Newton, second will be go above 1 Newton per mm square. 1 Newton per mm square, and you have here 40 means 10 raised to minus 4 Newton second per meter square mm square. But remember, here option is given in poise. Now you have to very careful what is poise. So remember the relation between your, that is 1 Newton second per meter square is equal to 1 by whether I am writing or this is correct. So you can just calculate whether that is your, not, this is not correct. 1 Newton per second is 10 not, just opposite relation. 1 poise is equal to 1 by 10 Newton second per meter square. This one, this is not. So once you will put here, what you will get? Just I want to show you. After the calculation, you will get this one. 1000 poise. So is there any option? No. So none of the above. Option will be none of the above. How you will calculate? This approach, remember. Another thing is the managing of your the units. How you will manage? As you can see here, your velocity first you convert in meter per second, dy also convert in meter per second, and tau is also you convert meter per second. So everything you will get in the Newton, that is the Pascal second means Newton. Pascal second means what? Newton per meter square second. This is the Pascal and second. And 1 Pascal second is equal to, as I have written here, that is 1 Pascal second, that is Newton second per meter square. As you can write, this is Pascal. So 1 Pascal is equal to, as you will multiply here, so 10 poise. This will also remember always. 1 Newton second per meter square is equal to 10 poise. Or you can say 1 poise is equal to 1 by 10 Newton second per meter square. So hope everyone got it. So if yes, you can write in the chat box yes. Yes, please. Yes, I want to see from your side whether you are getting or not. So you, anyone, please write the yes in the chat box. Then I'll move on the next question. Okay. This question is not very uh, tough because of the you have to understand about the how you will approach. Tau is equal to mu if the distance between the plate is very small in mm. So you can apply this formula. Tau is equal to mu u by y. Y here is the distance between plate. This type of question you can expect in the gate exam, also in your state exam competition. SSC also, nowadays SSC is asking some numerical type questions. So okay, so now we'll move on the next question. Next question is, okay, here I'll take 5 minute break. So for you I am leaving the questions. If anyone want to take the break, you can also take 5 minute break, or if you not, then you try to solve this question. Okay, so everyone come back. Okay, I'll wait 1 minute. Maybe participant will join. So here also I will share some this one, the link of my Google Drive. So you can go through that. Oh, this is not. This one. Here link I have given. After the finish the this class, so once you will click on the link, you will able to access. Now I have restricted your the access, but after this class I'll open. Or in the log sheet, the Excel log sheet you will also get, but I didn't have. I think Gulshan is trying to. So
First,
yeah, Gulshan, you will not get the access right now because I have already the content is uploaded. So after the finish the class, I'll just open for. I'll give the access to all of you. No problem.
practice.
Okay. So the question is about this question: if the dynamic viscosity of the fluid increase with the time under constant stress, the fluid is termed as rheopactic, thixotropic, Bingham-plastic, and pseudoplastic.
Rheopactic first answer.
Okay, rheopactic. Pramod is telling. Other student, please. Also, you try to give your answer. Other student, please. Just try to participate. Okay, Ravi is telling A, rheopactic. We are talking about here the dynamic viscosity of the fluid increasing with time. So here relation is, here is you have the three things. One is dynamic viscosity, another is time, another is constant shear stress. So tau you have constant, and with dynamic viscosity you have two conditions, decrease or increase, and increase only you have one condition, increase with time, and also you have the time also you have the condition increase. So any fluid which having the constant shear stress, under the condition of constant shear stress, as increasing the time as viscosity increasing, so this is the question, and that fluid is known as rheopactic, thixotropic, Bingham-plastic, or pseudoplastic. This is the question. So as student is telling A option, Ravi telling A, Gulshan telling A, Pramod was also telling A. So let me just show you the answer. So yes, rheopactic. So here all the your the plot is given. Remember please, this is very this diagram is very important for a competitive exam. As you know, with the time you can forget the examples or you will forget the concepts, but once you will remember these things, the graph, thixotropic, Bingham plastic and rheopactic, pseudoplastic, Newtonian, dilatant, and this is your plastic fluid and this is your ideal fluid. Ideal fluid, the definition was ideal fluid is what? The shear stress will be zero. If shear stress will be zero, so definitely your the ideal fluid will be on x-axis only, not on y-axis. Plastic fluid means your viscosity will be zero, so this is concept. And for Bingham plastic, you know already. For Newtonian fluid, you remember these three graphs. For Newtonian fluid, already I have told you. For Bingham plastic, that is y is equal to mx plus c. So remember, your Bingham plastic have some c value, means it will start from some c, remember. And similarly for dilatant and pseudoplastic, you remember these two things. And similar for Newtonian, just above one is pseudoplastic and dilatant. It have concept, remember please, this the graph is plotted here with the concept, not without the concept, but just for your remember, just I am trying to simplified way. The Newtonian fluid, the your link link with your pseudoplastic and the dilatant, and your Bingham plastic, near the Bingham plastic above one is thixotropy and another one is rheopactic. So remember, so the question was about the dynamic viscosity of fluid increase with time under constant shear stress. That is, shear stress is constant, but here you can see the shear stress is increasing as you the the rheopactic. I think the plot is not very here the shear stress is increasing, as you can see here, but here the question was about the constant shear stress. So this plot is not your comparable with your this the question. I don't know why it is given. So shear stress is a constant, means you have, this is, let us suppose this is your time, this is mu, then as time is increasing, whether mu also increasing, meaning like that your plot will be not like that. Let me just take this one like that. That is, time is increasing here, as you can see, the t1 time, t2 time, and mu also increasing, right? Mu also increasing with time as increasing. So such type of fluid is known as your rheopactic. Remember always, not tau. So one thing you can, why it is given, I can guess here, because your tau is related with this one mu, so that's why I think here given, but here time is also should be there. Okay, so no issue, but remember sometimes. So example, as you can see here, the gypsum bentonite solutions. For thixotropic, the crude oil lipstick and your pseudoplastic fluid, blood paints, and dilatant fluid is your sugar suspension and starch suspension, etc. So remember these things, little bit your theoretical point. Okay, which of the following fluid can be classified as Bingham plastic fluid, whether printer's ink, gypsum solution in water, human blood, toothpaste. Bingham plastic we are talking about. So remember what is the Bingham plastic as I have discussed. It have some C value. What is the meaning of C value here? So think on that and try to give your answer. Option D you are telling toothpaste. Okay, Gulshan is telling. Other student please also try to think. Whether you will wrong or correct doesn't meaning here. First you try to attempt the question. Let me in between I want to share my YouTube video because I have not the accessibility of this your Excel sheet where I'll upload the YouTube link and this Google Drive. So in between I'll write the mail to NPTEL team to give access to me for the updating Excel sheet. So in between please I'm going to share you just okay. So here a lot of question is given already. So let me just
Toothpaste D.
okay, okay, good. For you guys, I'm just
A printer's inks.
okay. Printer sync, good. So first, please everyone try to whether this YouTube link is working or not. Ravi is telling D. Pramod is telling printer ink. And another student who was telling the toothpaste.
Toothpaste I
Okay, Pramod is
told.
also telling the toothpaste. Okay. So for today video, you just follow this one YouTube link, and maybe tomorrow in the Excel sheet I'll upload the everything. So you are telling the toothpaste Bingham plastic. Yes, definitely toothpaste will be the correct answer. As you know, once you will apply some force on your toothpaste, then it try to flow. So toothpaste have some C value, that is some shear stress, then after try to flow like that. So definitely your toothpaste will be the example of Bingham plastic. Another example also given: dilatant fluid, butter, quicksand, sugar in water, and the pseudoplastic, paint, blood, milk, thixotropic, printer ink, enamels, lipstick, and the your rheopactic fluid, gypsum solution in water, bentonite solution, and the Bingham plastic fluid is sewage sludge, toothpaste, and the drilling mud and gel. So these are the example. Now which will move on the next question: which of the following condition is true regarding the validity of Pascal's law. First one, it is valid for idle fluid in motion. Second one is it is valid when real fluid with rigid body motion. So here you just think on that, what is rigid body motion. If you are very clear with this condition, so hopefully you will get the answer for this question. So first think on that. Statement 1 is wrong, okay. Gulshan is telling it is valid for idle fluid in motion, okay. So if option 1 is wrong, so what you are telling? Option 2 is correct or wrong? Which option is correct? Only one is true, only second true, both are false and both are true. Which option? So please everyone try to give your answer. Very important. So your next, I think next week will be on the fluid static. So in fluid static we'll discuss some, okay, B, yeah, C, not, okay. No, you're not unsure about the option number, second option, okay. So let me just, I want to give you a hint. The rigid body motion means all fluid particle have same velocity. All fluid particle have same velocity. This is the rigid body motion condition. Rigid body motion means, let me just give you, this is a rigid body, this is pen, whether it is visible or not. This is pen, I think it is visible, and this is rigid body. Once it is moving in forward direction, and this pen is have the millions of the particle, so all particle have the same velocity. This is the rigid body condition. Once car is moving, the car is having the millions number of particles, so it means once car is moving, all millions particle is moving with the same velocity. So that is the rigid body condition. Once you will apply this condition in the fluid, the rigid body motion condition means all fluid particle have the same velocity. If all fluid particle have the same velocity, you can think on that how you will apply. So very important question. So anyone want to tell? Another 1 minute I will give for this question. After this hint, if anyone want to give answer, you can write in the chat box. Okay, let me just show you the answer. So definitely both are true. How both are true? Let me just show you. The concept, the Pascal law states that at any point of fluid, the intensity of pressure is equal. The intensity of the pressure is equal in all direction. If and only if. This is with the condition. What are the condition? The shear stress acting fluid are zero. The shear stress acting on the fluid are zero. Meaning the Pascal law states that at any point in a fluid, the intensity of pressure is equal in all direction if the shear stress will be zero. The acting shear stress will be zero, meaning Newton's law of viscosity you know already, and the shear stress is zero means what? It is valid for ideal fluid motion, means ideal fluid motion means what? Mu is equal to 0, as I have earlier told you. So if mu is 0 and formula is this, if mu 0 then shear stress will be 0. So definitely here your Pascal law will be applicable. Option 1 is correct. Therefore Pascal law is valid for ideal fluid even in a state of motion. State of motion here we are talking about, remember please. State of motion means velocity is not 0 but your mu is 0. Mu 0 means shear stress is 0. Generally, remember please, it is valid for ideal fluid in motion. Pascal law, generally we discuss about the Pascal law in your static fluid, in a static. But here the condition is given, the fluid with ideal condition. Fluid in motion with ideal conditions. Now the second one is, it is valid when real fluid with rigid body motion. Rigid body motion means all your velocity, all fluid particle have velocity, uniform velocity. So change in velocity will be 0. If change in velocity will be 0, so tau formula is mu du by dy. So if this is 0, then mean all your term will be 0. So meaning here also applied. For real fluid, Pascal law is also valid with rigid body motion. Meaning Pascal law is valid in motion condition also, if your fluid is ideal, if fluid with having the condition of rigid body motion, or you can say the uniform velocity. So hope everyone got it. So please just you try to write your answer in the chat box whether yes or not, then I'll move. This is very important concept. Anyone please, you can write yes. Okay. So if not, if anyone having doubt, you can also write no sir, then I'll again explain. This is not hard and fast rule. You always write yes. If you got, then you write yes. Okay, hopefully everyone got it. So now we'll move on the next question. So next question is very simple question. YouTube manometer. So a YouTube open at both ends and made of 8 mm diameter glass tube has mercury up to a height of 10 cm in both limbs. If 19 cm of water is added to one of the limb, what is the difference in mercury level in the two limbs at equilibrium in centimeter? So please everyone just first try to think question, try to solve the question. This is your 5 minute I'll give for this question. So everyone please try. So in between, I want to just write one mail to NPTEL team regarding to allow me the access. Okay. So please everyone first try to solve. Very important question. Okay. So anyone trying? So if anyone got the answer, please you can write in the chat box. Very simple question, interesting one. Okay, let me just discuss. So here condition is given. Remember two things. First you try to understand the question and then you try to solve. The first U2. So here we have the YouTube manometer. This one. Diameter is 8 mm. The diameter is 8 mm. This is okay. Now the glass has mercury up to height of 10 centimeter in both limbs. So here we have the, let us assume from here it is 10 centimeter. In both sides 10 centimeter is given already. Okay. Now if 19 centimeter of water is added, centimeter cube here is given, means volume 19 centimeter cube, meaning area you know already. If I try to write in mm, 0.08, this is meter. So area pi by 4 into d square. So pi by 4 into 0.008 square. So this is area. So how much your height? If you will put here the 19 centimeter cube of water, so how much height? So height is divided by volume by area. So volume 19 into in meter cube, so 10 raised to minus 4, and here is area is pi by 4 into 0.008 square. So 10 raised to minus 6 here will be. So now what will be the your H? Anyone can tell? What is the value of H? Anyone solving? Value of H. Okay, let me just discuss the concept, then I'll show you the answer. How we will approach. So first you will find this H. So once you will put the water, what will happen? Let me just, initially was your 10 centimeter height. Once you will put the water, your mercury level will be down here. Initially height was up to this. your mercury level will be down. Let us suppose the here, and in this limb your mercury level will be increase, that is here, new one, and this is your mercury. So now the question is asking about the difference between these two height. That is the question is asking about this. Let us suppose if I write with y, so question is asking about y, how much y. So one thing remember, once you will put the water here, so first you try to, once you will put the water, how much this distance is going down. Let us suppose y1 is going down. If y1 is going down, then what will happen here? The same, if the initial height was this much of the mercury, so this much will be increase, that is y1. If y1 down, then y1 will be increased in the second limb, definitely second, and initially, and the question is asking about y, so what will be the y? So y will be this y1 plus from here to here y1, and this distance is another y1 plus y1, so the difference will be the 2y1. So how you will calculate this y1? This is very very important. Once you will put the here water, so your the distance is this much. So first you will try to find out the height of water. So how you will find out the height of water? You will get like that, height of water. Then you will write the formula. That is the pressure difference, the pressure balance. So here is the atmospheric pressure, PA. Here also is PA. So you can write PA plus, here the water density is not given, we will consider here 1000 kg per meter cube, and I think mercury density is also not given, so we can consider here 00 kg per meter cube. So you will write PA, then you will go down, and this much is area here is, that is rho of water into G into y1, rho of water, remember, and then this height is, here is mercury. If you will come up to that, you will write this one in positive and you will write this one in negative, that will be cancel out, so we'll move from here. So now equal to PA, for this limb I have written, and after the equal to I am going to write for this one, PA plus, that is PA plus this y1 and this y1 means 2 y1 is equal to 2y1 into rho G, rho of Hg into G. So from here you can calculate, I think we are doing somewhere mistake in this part, because the y1, this one, the height will be the y1, and okay, this will be not y1. Why it is not y1? Because your mercury level is, the water height will be not y1, I think, because the density, as you can see here, the rho of water and the rho of your mercury is very very high. So this will not mandatory. If your water you will put like 19 centimeter cube, so if the water height is increasing this much, that is let us suppose 10 centimeter, so it is not, the same height will not increase in the mercury. Why? Because of this, the difference is this, the difference in the your density is very very high. So this, if y in the in your water, if y1, so here something will be different, y2, here will be y2, so not y1. So you can write here this much. So for mercury you will write here y2 and initial your, that is this one. This much distance you can write here, y2 plus y1. So like that. So from here you will calculate this one, this your, and how you will calculate this y1. So 10 minus you can do this. So 10 minus y2, if you will write here, so you will get this this y1 and y2 difference. So here in a simplified way, it is already explained very well way. So I'll just show you the complete analysis. So the explanation part is visible, please. Anyone can? Explanation part. Yeah, okay. So now just I want to tell you very in simplified way how, initially I have just told you how you will approach this question. Now I'll just show you the step by step how this solution is done in this slide. Oh, sorry. Okay. So here as you will put height, so similar you will calculate here the height of the water. The height of water is coming. How you will calculate? As I have told you, just you will the volume of water is equal to area into height. So from this relation it is calculated your 37.8 centimeter. Okay. Since due to the addition of water, the Hg level will fall down by x centimeter in the left limb. Definitely once you will put the water, the height will be fall down of the this mercury in the limb. So in the right limb it will be rise by or risen by the x centimeter. If x centimeter will fall, then here x centimeter will be increase. Okay. Now take the reference level as f. Why it is taking f? If you are taking here the f is reference level, because this is mercury and this is also mercury. So once you will write for this limb, this up to that your the value will be cancelled out, because this will be, what you will do, one, this is the left hand side you will write left hand side limb, and this side you will write the right hand side limb. So definitely this value and this value will be same, so it will be cancelled out. That's why we are taking the reference level here. Now so now we'll move on the this one. After adding the water, so water height is how much? Water height is given you 0.378. 0.378 means in meter, if you will write 0. That is in centimeter 38.37.8. Here it is written very clearly. So in water limb, first you will write the atmospheric pressure here. So that's why written is atmospheric pressure. Then rho already, and rho of water, g, and height how much? Height is your this much 0.378. So for this left limb it is completed. Now we are writing for this limb here. So pressure, atmospheric pressure is given already, yes, and Hg. So here we are talking about Hg means the your density of mercury, and G and X, capital X is given, and here is small x is given. Not capital X, because X is here down and another X is going up. Okay, so here in the mercury level already 2x is given, because this x and this x. So 2x is given. Okay, previously I was telling, I think by mistake. So here I was considering previously the height of y is this much, not the water height will be the very high. So if you will put this much height of water, so your mercury will increase little bit, this much. Mercury will increase this much because of your density difference. But here now it is very clear. So okay, so here we are written already total height. We are considering the total height here up to this. Total height, rho g, total height we have considered. And once we are going to write this one, so, and why it is written here as x similar value, because the light density of water, light density of liquid, as we will put the small amount of, if this density and the mercury density, mercury or you can say the other liquid density will be equal, so this much, when you will put this much water, so this much height will be increased in this limb. But here it is not the case. Here is the case is the mercury density is very high compared to this. So once you will put this much height in water, the small amount of height will increase in the x, or a small amount of height will be fall in the y, fall in the Hg, mercury. So a small amount of fall here and a small amount of increase here, as you can see. That's why it is x here is fall and xy increase here, both are equal. So that's why it is written for right limb rho a, and x is this one and x is this one, so it is 2x. So as PA will be cancel out, and here 13.6 and your G value is means 13.6 means why it is given. So a specific gravity you know already, the specific gravity of your mercury is 13.6. once you will convert in your density, so 13.6 is specific gravity into the 1000, that is the standard liquid density. So this is, and 2x is already given, and Gg also will be cancel out. So once you will calculate, your answer will be 14 centimeter. 14 centimeter, the value will be x, 14 centimeter, but your difference is 2x, means the difference will be 2.8. So hopefully everyone got it, the concept behind this question. So very important question, you can expect such type of question in your final exam of fluid mechanics, NPTEL or exam, or GATE exam also. Another exam also you can expect, not the exact question. So everyone got it? Please you can write yes in the chat box. Yes, please, everyone write. Okay, thank you. So hopefully you all enjoyed this session. So we'll meet in the next session, that is tomorrow, the same time 7 to 9 p.m. and we'll discuss more questions, more interactive questions, more important questions. Okay, thank you. Thank you all. So now,
Thank you, sir.
okay, thank you so much. Now you can leave the class. Everyone please leave the class.